Hello, my name is Harold Scott Roth here with the Hudson Institute. It's my great honor and privilege today to welcome Professor Karen Cucci to the Hudson Institute and the Center for the Economics of the Internet to speak about 6G. Professor Karen Cucci holds a position as professor in the Department of Electrical Engineering at the Indian Institute of Technology at Hyderabad. He spearheads research and standardization endeavors for 5G advanced and 6G technologies on behalf of India at international standards organizations focused on shaping the future of communication systems. With a prolific portfolio, Professor Cucci boasts over 200 international patents, including some recognized as essential patents for 5G standards. Notably, he is the founder of WISIG Network Private Limited, a venture incubated at the Indian Institute of Technology at Hyderabad, where collaborative efforts between IITH and WISIG have led to the development and commercialization of 5G base stations and user equipment technologies, as well as NB-IoT system-on-chip solutions. Professor Cucci is a remarkable organization at the Indian Institute at Hyderabad and is developing world-leading technologies there. And it's a great honor to have you here at the Hudson Institute to teach us about 6G and the future of wireless technology. Professor Cucci.
Thank you, Harold. It's a pleasure to be able to talk at this on this occasion. I recall that we did speak on 5G a few years ago. I guess time flies fast. And there we are talking about 6G, although it's not there yet, but I think it'll be there sooner than later. Welcome to all of you who are listening to this talk. I have been associated with the development of many cellular standards, several generations, most notably both 5G and 6G. I'll be happy to share some of the most recent happenings and updates from this 6G world. Throughout this talk, you'll hear this name, IMT-2030, also known as 6G. I'll talk about it more. What is this IMT? While 5G rollout is more or less getting into a fairly mature stage across many geographies, both United States, India, and elsewhere, ITU has embarked on a new project called IMT-2030. So this slide has this timeline, and 2030 is the closure of the project. And interestingly, 2020 is the beginning date for this project. And the previous project, so-called IMT 2020, ended in 2020, which is 5G. It's very interesting that ITU has this program in the working party 5D. Every 10 years, they start a new project in this so-called IMT program that delivers more or less a new G. We are into the 6th generation right now. This is kind of looks like a ritual that just keeps happening every 10 years. So we are in, at the end of this so-called framework phase. This is completed. The first piece of this 4-stage program, the first piece has been accomplished. In June 2023, there was a meeting in Geneva where the so-called IMT 2030 framework document has been published. This includes the vision, requirements, and the plan for the execution of this so-called IMT 2030 projects. Right now, around the world, the framework document especially on the basis of the so-called framework document, the vision document. A lot of 6G R&D has been initiated because the vision has been laid down, requirements for 6G are being worked out. So the whole industrial and academic machinery, as well as the government bodies, have really moved into action in funding the R&D, developing the prototypes, trying to figure out what 6G is. A lot of work is happening. So I'll be happy to share some inputs. Of course, the standards development will happen a couple of years from now. Right now, we are still in the early days. By 2027, 28, you'll see some of these so-called 6G standards are out. And by 2030, the products will be rolled out. So this is kind of the high-level plan. So I have this picture I like. This was taken in celebration of the outcome of this meeting number 44 in Geneva, June 23. We just concluded, I was part of this meeting, we just concluded the approval of the 6G framework document, so-called vision document. I'll show the details. And people were very happy to get this thing done. You can see United States, the FCC representative here, and you have AT&T, people from other countries. You can see me here. It was really a fun week, very intense week though. 2 weeks of lots of hard work that resulted in the vision document. So what is this 6G vision? It really nicely summed up in this slide. Actually, there are 2 slides I'm going to present. More or less, the whole vision is captured into this. There is a circle, there is a polygon here, and there is a triangle. There are all kinds of shapes. Let me just take a deep dive into this. The middle part includes 3 vertices of this triangle. You can see IMT-2020 is part of this picture. That is 5G is part and parcel of 6G. That's what it means. It has 3 services: enhanced mobile broadband, massive machine type communications, ultra reliable low latency communications. There are standards defined as part of the MT-2020 process. They're available. We all know that 5G has been rolled out, so-called enhanced mobile broadband, which is basically, use the smartphones to get higher speed. That's what it kind of means. Maybe sometimes internet access to the home for those who don't have a fiber. Massive machine type communication is connecting meters, sensors, devices to the cellular internet directly to the base station. It's still something, a growing market, expected to grow further. Ultra reliable low latency communications, it's still not has happened. I think many of us know that. Maybe the time is not ripe yet for that. Hopefully in the next 5 years or so, we will see this new technology taking off. But the community at the Working Party 5D, the participants include cellular operators, vendors, equipment vendors, device vendors, chipset makers, governments, academia. They all sat together, large group of people. They can define this vision document in this particular form and shape. It took them about a year or 2 to get to this outcome. Of course, there's a very nice document available. It's also called framework document. You can download from ITU website and read that. Now, what is 6G? Each of these 3 services, you see the arrow marks, they're going to evolve further. You see the color coding. Enhanced mobile broadband will become something called immersive communication. These little dots here are called usage scenarios. So for example, in 5G, there were 3 usage scenarios: EMBB, MMTC, and your others. Now, In 6G, we have more than 3, kind of doubled, more usage scenarios. Among these more usage scenarios, about 6 of them, there are 3 of them with green color. They're kind of evolution of what exists today. Enhanced mobile broadband becomes immersive communications. Massive machine type communications becomes more massive. Ultra reliable low latency communication becomes, well, more reliable and more lower latency, called hyper reliable low latency communication. Just the performance boost of these existing features. So these 3 services are being expanded with an inclusion of 3 more new services. These are really new. Integrated sensing and communications is really a new thing. What it really means is that the cellular base stations, macro cells as well as small cells, they can be used as sensing devices. The applications are very many. For example, you can use them as location finding in the factory floor or at the homes or outside to detect flying objects, drones, in this simplest possible manner as a radar. You can use the base station as a radar. It has all the things you need to include a radar functionality. We don't call it radar anymore. It's called a nice name called sensing. This is going to be real when 6G is rolled out. It will have a dual usage to be used for both sensing and communications. There are all kinds of new applications that will come out of this new research scenario. And the interesting one is the integration of artificial intelligence and machine learning into communications. One may wonder why communication is integrated with AI. This happens at different layers of the communication chain, both at the device level as well as the radio access network level in different forms of chips. A fairly straightforward way to understand how AI is used is to do data collection from the radio access network, collect large amounts of data, related to many different aspects of the network, and use this data to analyze and improve the network performance. Not only to improve the network performance, but also take certain actions to optimize the network without human intervention. That is, a true self-organization is the ultimate goal of some of these new features coming up. AI is also being envisaged to be exploited at other parts of the radio network, at different layers, physical, MAC, radio layers, as well as in the device side. Of course, device level AI usage, especially with chipsets and large language models and all that, that's a different realm altogether. So anyway, there is going to be an integration between a device that uses large language models, small language models, and then use 6G as a communication medium, and then we have a combination of 6G and AI-based communication. So it's very interesting what could possibly happen in this domain. I'll have more examples of these new research scenarios as we go about in the next few slides. There is something called ubiquitous connectivity. There's a long debate about this. This is something, my own research group working with the government of India proposed this as a new research scenario. The goal was to make sure that in countries like India, where there's a large population living in rural areas, where population is more or less uniformly distributed throughout the geographical territory of India, which is really different from other countries. They're more urban-centric. So connectivity has always been an issue in the sense that you can't bring fiber everywhere in a vast country. And there must be methods, ways, and means to take the connection from the fiber drop point and still connect people using very large cells or maybe other techniques, still terrestrial communications. This was debated quite intensely, and finally India and United States government, they worked very closely a deal was negotiated to include this important use case as a usage scenario for 6G. Other than that, there is sustainability, ubiquitous intelligence, security, privacy. These are very important aspects. And then there is this connecting the unconnected. Hidden in that is the satellite part. So going into the June meeting, a number of countries proposed satellite or so-called non-terrestrial networks to be part and parcel of 6G. But at the end of the meeting, the conclusion was that satellite and NTN is not part and parcel of 6G as far as Working Party 5D vision document or the deliverables are concerned in terms of defining the radio performance. However, Working Party 5D recognizes that terrestrial 6G will interwork with satellite systems. So you can build satellite systems outside of Working Party 5D and then define interworking procedures. This is the framework and the agreement made at the ITU. As far as the capabilities are concerned, this is again a deliverable of the ITU Working Party 5D in the same meeting. There are existing technical parameters, example, reliability, mobility, latency, spectrum efficiency, data rate. All these metrics do exist, well defined in 5G. They're carried over. Those definitions have been carried over. But of course, performance targets have been enhanced. You can see these numbers somewhere here. A range of values have been specified for certain parameters. And these range of values are called research targets. So in the next 2 years, one has to kind of select a single value from this range of values so that you can set the technical performance requirements for the standards to be developed further. But then they see the color coding, there is these blue things, they are new. They are new. They are new because they are only part of IMT-2030. They did not exist before. They're new because there are new usage scenarios. Example, ubiquitous connectivity. So you need to define coverage. The scientific definition of coverage was introduced, and coverage is given a special status that with the understanding that 6G will provide much more coverage than 5G does today. Sensing related capabilities will be defined in the next 2 meetings, especially there is a meeting coming up in June, just a few weeks from now in Geneva, where most of these parameters will have scientific definitions, and then ITU will start working on defining test cases, evaluation exercises, and eventually standards get developed. AI-related capabilities, but there is this new thing called interoperability that actually an operator, friend of mine from India, Reliance Jio, he kind of asked me to bring this to ITU. We worked together, and before going into the June 2023 meeting, this was not included, but then we finally end up including this with the support of the member states and the vendors and operators. This is a big deal, interoperability. What does this mean? It means the various subsystems, well, the way I understand, the various subsystems of the 6G system will have open interfaces, and the subsystems are interoperable. It kind of sounds like Open RAN, kind of coming, like getting into 6G. So 6G seems to be, by definition, maybe Open RAN compliant, just to put it in a layman's language. But of course, it's we don't want to make such large statements that it is exactly Open RAN compliant, but something like Open RAN compliant. So time will tell exactly how these specifications will evolve in ITU, or inside the United States Open RAN standards bodies, 3GPP. There's a lot of work ahead. Okay, so that's very interesting. Interoperability is part and parcel of 6G in addition to satellite component. As far as the applications are concerned, I think there is a lot of talk about 5G, I guess, not having very many killer applications. That is something we have to deal with. I guess there's no easy solution as such. But that doesn't mean that we don't evolve the technology further, anticipating new applications. One example is that there's a lot of push for yeah, XR, AR, VR, XR type of new applications getting into 6G with new devices coming in, requiring extremely high speed, reliable internet connections, wireless internet connections, super high speed communication. So that's still going to be a driver for 6G, this immersive multimedia. There's a lot of focus on digital twin and virtual world. It's kind of related to that. Connecting the unconnected, especially in the terrestrial mode, underserved areas, by providing large cells with higher coverage, using 6G equipment for dual purposes, both as a sensor as well as a communication system. There's a big demand from various operators to enhance the energy efficiency, make the system environmentally friendly. So there's a lot of push for that. Computing is going to be a big part of this. Devices will get smart. They'll probably change in form and shape. A lot more computing goes into these devices, and intelligence distributed everywhere, right from device to the network level. So lots of new applications are being envisaged through these new usage scenarios. As far as more precise timelines are concerned, 2024 to 25 is the phase for technical performance. So we're doing this as we speak this year and next year. ITU Working Party 5D has been working on that in the next 2 meetings. You can see this technical performance period. 2025-26 and beyond, maybe up to 2028, specification development, standards development. As far as ITU is concerned, there will be technology proposals received, evaluation will be done, consensus building, and then there will be an outcome and decision at 2029, resulting in so-called IMT-2030 specifications. So I guess 2029 is when the vendors will be more or less ready to roll out these new products. So I also want to give you a bit of a view what's happening in India, especially with reference to 6G. I think last time I spoke at the same event, I mentioned that India was very serious about getting into standards, developing 5G. The effort was moderate. Many contributions have been made to 3GPP and ITU by Indian organizations. Excuse me. Back then, it was predominantly academia, and industry was practically non-existent at the time in 2015, working on wireless communications. So I was really deeply involved in this effort. We created a lot of intellectual property, submitted to these bodies, standard bodies. But the global, as a percentage of the global share, it's really a small amount. But nevertheless, it's a good starting point. As far as the 6G is concerned, I think things have changed quite a bit. In 2023, the Prime Minister has released the so-called Bharat 6G vision. Bharat stands for India. So it's kind of like India 6G vision document. And there's a bold aim of aiming for 10% of the global IPR over the next, I guess, decade. And also the shift from academia to industry, because it's industry that has to really take the lead. India has been, especially the Indian government agencies, have been funding this effort for the last several years. But I think more needs to be done. These are discussions happening these days. And there is also so-called Bharat 6G Alliance. This is equivalent to the alliance in the United States, NextG Alliance. Bharat 6G Alliance is the counterpart. We've been working with NextG Alliance. We've been working with the alliances in Europe, Japan, and other places. Working groups have been established. I've been doing some work in this space. A lot of action around 6G development overall. Okay, so since I'm a professor, I have to wear the professor hat and say something about the technology, which is what we do on a daily basis. Those of you listening, you might be wondering what's new left, because 5G has just been concluded. What more needs to be done? I'm giving some topics here, laying down some ideas. But of course, this is by no means this is an exhaustive set of ideas, but I kind of picked the most prominent and maybe ones that have a likelihood of getting into the standards. Waveforms is really important. With every generation from 2G to 3G to 4G, the standards have adopted a new waveforms more suitable for the generation at the time. 4G to 5G, the change in the waveform has been more incremental. It's still based on OFDM and some variants of that. In fact, our group has proposed a new waveform in 5G, mostly for the handsets. That's now part of the handsets. So there is always interest in new waveforms as we move towards usage in the higher frequencies, energy efficiency, low latency. I'll talk about this particular aspect a bit more detail in the subsequent slides. Our research group has been very active for almost more than a decade in building large-scale MIMO systems that used to use lots of antennas to increase the communication system efficiency, whether it is spectrum efficiency or coverage or data rate. Been doing a lot of work in this space, and there is something called structural MIMO, extreme MIMO. There are lots of new jargons that have come up. I'm happy to say that we did an experiment that kind of indicates we can achieve up to 100 bits per second per hertz in a base station. This is quite realizable. Of course, there's no free lunch. You have to throw a lot of hardware and software at it, and maybe a little bit of more physical space. So having more antennas, at the base station always gives you more. That's good news. But of course, one has to control the power consumption, cost, and other aspects. The same kind of antenna technology can be used in a different way. You distribute the antennas in different ways inside the buildings, in different places, and use cooperation among these antennas to achieve more bits per second per hertz. These are promising candidates. Other than these two physical layer improvements, which is to improve the bit per second per hertz, fundamental metric of efficiency, there are other ways to bring system level improvements. One is using non-terrestrial networks, whether it is low orbit, medium orbit, or geosynchronous satellite systems, or even high altitude platforms. I guess this is going to play a significant role. Although now Working Party 5D didn't kind of include this into the 6G framework, they'll be outside the 6G framework. But 3GPP has defined these standards. They're available. Products are being developed as we speak, and they're already available. But an integration between these systems and 6G and 5G is inevitable. I guess there is already evidence that there is satellite communication systems are already in the phones. Lots of activity around this. There's one more interesting aspect for wireless communications. We always use this notion of base stations and phones, and then phones connect to base station. This is basically a sort of a network architecture that's been around for the last 40 years. But as systems move towards high frequencies, one has to really think and rethink whether this is the right way to go about it. If I have a 700 megahertz system, I put a cell site and so half a kilometer, 1 kilometer, or even more, so lots of users. This works well. But as we move towards higher frequencies, the radio propagation environment is not very benign. Signals attenuate, buildings block the signals, obstructions block the signals, there are lots of issues. I'm sure even 5G faces some of those issues. And the fact that the phone form factor is going to be about the same, it can only become smaller, and they're not going to be a whole lot of power or battery that can take the transmission signals to a farther distance, because there are limits on radiation, SAR, and all that. So considering all that, I think there is probably a need to rethink how to carry the cell phone signals to the cell site. Maybe, a direct communication is probably not the best way, at some point. One has to look at maybe more than one hop, 2 or 3 hops. Well, this is quite revolutionary in the sense that cellular communications are not built around these principles. But I think at some point, these kind of alternative topologies will come into play. I've said something about machine learning, artificial intelligence, but this is all pervasive. It's getting into many different aspects of our daily life, not just communication, it's everywhere. So we expect to see some of these new things getting into IMT 2030. I will take just a few moments, maybe no more than 5 or 10 minutes. We have invented something new, so I'll describe what it is. It's a new waveform for 6G. I will not get into a lot of mathematics, the physics of how this works, but try to give you a glimpse of what it is. IMT 2030, also known as 6G, has new bands of interest. Considering that the mid band is already used, there is a growing interest in the upper mid band, so-called frequency range 3, FR3. That's basically there is the 6.425 to 7.125 range in some regions, or 7.125 even up to 13 gigahertz. This is a frequency that's of interest. I guess there are lots of other users occupying these frequency ranges, but some space might be available for 6G, because there needs to be a new frequency for 6G to be deployed. Well, there are already, higher frequency ranges, above 13 gigahertz, they're already part of 5G. But the question here is, what is the kind of waveform that's most suitable, that is suitable for the 6G transmissions? The ITU Working Party 5D has laid down some requirements. There are 3 key critical requirements, important requirements. One is called hyper low latency. Well, the idea is to transmit information in the least possible amount of time. One country, I think it was Japan, who proposed 100 microseconds as the latency. That is, takes no more than 100 microseconds for the information to be transmitted from source to destination over a wireless channel. That's probably an extreme requirement, but nevertheless, it's been proposed. So in order to realize such hyper low latency, we will need to revisit our known waveforms and see whether it's something that needs to be done about it. So it's a single shot transmission. Just you send one waveform and you carry all your information that you want to convey in that single transmission. And there's also an interesting new requirement, the mobility support. 5G supports up to 500 kilometers per hour for high-speed trains. Well, this could possibly be revisited to 1,000 kilometers per hour. And not necessarily trains. Of course, the train speeds have not changed a whole lot. But not necessarily drones either, but maybe ground-to-aircraft communication or something like that. So there is a need or rather a requirement coming up, more than 500 kilometers per hour speed to be handled in the next generation. And most importantly, the green, that is the efficiency of the energy or power. Some waveforms are notoriously power hungry. They're not friendly to energy consumption. There are others that are, more reasonably, maybe friendly to lower energy consumption. So we wanted to come up with one waveform that meets all these 3 requirements, and it turns out that the existing systems There's a lot of jargon here. This is available in 5G. This is available in 5G. There are two waveforms. But both of them do not support all three requirements at the same time. They support maybe two out of the three, but not all three that we talked about. There are three requirements. So a new method has been developed. It is orthogonal frequency division multiplexing, but there is a word inserted here, orthogonal time frequency division multiplexing. So we slice a signal in both time and frequency at the same time. That's our kind of idea, and it can be accomplished in a fairly straightforward manner once we describe the solution. Of course, it was not done before, and it does solve the three problems or three goals that we wanted to accomplish. The three. Okay. This is a very complex circuit diagram or a block diagram for somebody who is not in this field. But all I can say is that this middle box is available today with some modifications. The rightmost portion is OFDM. It's available. It exists. And the leftmost portion, with some modifications, the existing technology, and adding something new on the leftmost portion, we can actually build a new waveform that meets all these operations. So the fundamental framework of OFDM can be leveraged. We don't need to make wholesale changes to the circuits and systems that are available today. Make a change in a rather acceptable manner to create a new waveform that actually solves you the three requirements stated above, the important three requirements. Okay, in summary, we talked about 6G vision requirements. We talked about non-terrestrial satellites. We talked about integrated sensing and communications, AI coming into the picture. And new usage scenarios are being introduced. ITU is on track as per the timelines. 6G is still a few years out, but I think a lot of work is being done. And we always are interested in making very fundamental contributions from our research groups. We introduced a new waveform. We've been talking to vendors, standards bodies on how to exploit these new methods advantageously for the introduction of these systems into 6G. I will stop here. Happy to take a few questions. Thank you very much.
Professor Cucci, thank you for an outstanding presentation. I've learned a lot. I'm sure our audience has learned a lot as well. I'm going to follow up with a few questions here. You mentioned the aspirations of India for 6G and the increased role that India hopes to play in IMT-2030. And is this a government-led effort, or is it educational institutions and private sector? Or tell us a bit about the focus of India's efforts in 6G.
Yeah, thank you. So, years ago, I think it was around 2015, I started this whole effort of going to standards, doing something. That was mostly driven at the educational institute level, myself, my colleagues from other educational institutes. Then slowly the team sizes has gone up. Then things have changed. India has started asking for Indian companies to supply wireless communications equipment. This is already happening. There are some laid down procedures and requirements to create radio access technologies within India. Now, coming to 6G, there is actually a 6G vision document published by the Prime Minister Modi in 2023. And actually, I happen to be one of the authors of that vision document, along with some of my colleagues in academia and industry. The vision document is published. It's available on the Government of India Department of Telecommunications website. So we are following through to implement the vision. And as part of the implementation of this vision, contribution to standards at ITU is one of the deliverables of that program. So as part of that, we started contributing to Working Party 5D. And it turns out that this is the first time India has actually contributed to a standards program right at the beginning, because in the last cycle, my team started doing this in the middle of the cycle in ITU, but this is right at the beginning. That's when we encountered these interesting conversations, when we introduced new proposals. We had a pretty good collaboration with the United States. We had some tough conversations, but then in the end, we agreed to introduce some proposals jointly last year. And we got a few things done, but I hope to work with not only United States, but the other regions also to ensure that India's requirements are projected and like you can see is a whole list of things that we have mentioned here. We have a long road ahead, but I think progress is being made on the ground.
I think it's interesting to note that yeah, I'd say there's some quarters in the United States that have think that U.S. efforts at the international standard setting bodies have not been as well coordinated as they could be. I'll put it that way. And yet other countries such as China have been very organized, very disciplined in how they approach these standard settings bodies. And it's interesting to hear that India is trying to be more organized and coordinated as well. I think it shows.
Yeah, we are trying to be as disciplined as possible. It's never easy because there are private players and the public players and other countries. But being a newcomer, it's rather less difficult to coordinate and have a single voice. As time grows, it becomes harder and harder, as you
know. Switching to just more conceptual issues, AI has captured the imagination of a great many people around the world. And it's fascinating to hear about the potential integration of AI into 6G. And it falls into some of the topics that you were describing, both in terms of energy efficiency and latency. So conceptually, you put in a network, you put the intelligence computing at one location, depending on, in essence, the cost of computing and also the cost of communication, the latency of communication. And your description of AI is in 6G is fascinating because on the one hand, it could be that if AI requirements are so extensive, then you may want to put more intelligence, say, in the handset or remotely at the user. On the other hand, if the cost of communication falls rapidly enough, then you would want to put the intelligence at a remote location to capture economies of scale there. Tell us about your thinking about how this evolves. I mean, I've heard estimates of the increased energy requirements for AI associated with internet search as being about an order of magnitude greater, that every time you do an internet search with AI, it costs about 10 times the amount of energy. How does this all fit together? I'm sorry, that was not a very well question.
Yeah, actually, you hit the right spot here. While today we're talking about communication, let's pause for a moment on the communication part of it. Let's just focus on a cell phone using GPT-like tools. And I mean, it seems like it's inevitable that the operating systems themselves will look a lot more different a decade from now. in terms of what they're capable of, what they would be doing. And then you ask the right questions. Are we going to pose a question and send this data to the cloud and solve all the uh, use all the compute in the cloud and then bring the result back? I mean, that's very unlikely. The amount of bandwidth and the link speed you need and the reliability you need is going to be a lot more. So it is inevitable that the large language models become smaller and smaller, that they can actually fit into the device. So you might do a lot of local compute using moderately sized language models. And you still need maybe assistance from the cloud. And then there is this wireless medium in between 5G, 6G, and you have to have some requirements on that, on the latency, reliability, availability. It's really going to be a very interesting interplay between communications, computing, and AI. They look like they're different things, but they're all acting simultaneously, one depending on the other. A lot of interesting times ahead. Just this interplay itself. So very interesting things are bound to happen.
You also mentioned the relationship between satellite and terrestrial 6G, and that, and I assume it's kind of questions related to latency that limit the integration of satellite being entirely consistent with 6G standards. Can you tell us a bit about how you see satellite fitting in with terrestrial 6G networks?
Okay, so as far as low bitrate communications is concerned, it's already there in the phones, right? Apple has it. I think Android has it. Many cell phone makers have integrated an SOS, a short message
Yes.
or a message service. That's done, right? That's the low hanging part. Now, when you go out of coverage of terrestrial, you need a fallback to satellite. The question is whether the distance to LEO orbits is not large enough to be able to get an adequate signal with the right kind of device antenna to be able to do the communication. It seems like we're getting there. I don't have all the data with me, but we're getting closer to that. Devices connecting to LEO orbits. Still a lot of hard work, because if you see Starlink devices today, they have very large antenna pointing to the sky, right? So it's not a mobile device. It's not a mobile phone. It may be mobile, but it's not a mobile phone. So we still have some hard work left to be done, getting reasonable broadband speeds into the phone. This is the research target. But on the other hand, the satellite can be used as a backhaul practically anywhere. You can always use it as a backhaul medium and then just connect phones, right? That's the easy thing to do. Today, Starlink does that with Wi-Fi. So in a way, it's there. Today, our smartphones connect to, in fact, I've done this myself as a little experiment when I was there in the United States a few weeks ago. We ordered a Starlink device, and we connected a few phones with that. So you have a moving base station with you. So it's there. So from that point of view, these low orbit satellites are there to act as a backhaul anytime, any day. So you can have moving base stations.
Yeah.
Yeah, so it's there. Maybe the question is whether the phone gets this direct connection or not with high enough speed is still not answered affirmatively.
You alluded in your talk to some of the challenges that the 5G operators have had, and that consumers haven't really seen a killer app, if you will. And the carriers have invested, each of them tens of billions of dollars in 5G networks. Tell us a bit about what you're hearing from both the equipment manufacturers and from the carriers about 5G going forward and a transition to 6G. How do you sell 6G? And some of the carriers have had a lot of financial troubles with 5G.
So Harold, there is no denying that there is no killer app for 5G. Until that killer app is found, 6G will not find its groove, right? So it's a device. It's a device and it's a new application that's totally missing. We can talk about fixed wireless access and all, especially in places like India, you can use this 5G as a fiber replacement, but that's not what 5G is primarily meant for. It's just another use. So new devices that demand a lot more speed, especially in the uplink direction, giving new user experiences is required. If you just give more speed in downlink direction, maybe you consume a lot of Netflix. That's about it. Okay. But I think having the requirement to have a fat data pipe from the device back to the base station. Once this requirement comes, 5G cannot handle it. Today, 5G gives you a few Mbps or even less in the phone to base station direction. It's called uplink. And it gives you hundreds of Mbps in the other direction. It's highly asymmetrical. So on one direction, we have super high data rates, but not in the other. But when new devices come into play that demand a lot more speed, reliability, and coverage, then you need a new generation beyond 5G. That's, I think, inevitable. But again, the holy grail here is the device, new application. Probably we are a few years away. It's bound to happen sooner than later, but we're all going to wait for that new thing, whatever that thing is.
Professor Cucci, I would be remiss if I didn't ask you about your latest research efforts at WiSig. I think you are sort of ahead of the technology curve in a lot of areas. I know you've been doing a lot of work on massive MIMO in recent years. Tell us about the things that you're working on at WiSig now, and as much as you can about what you're finding.
Yeah, thank you for asking, Harold. First and foremost, just a few weeks ago, we launched a 5G network that we designed over so many years in our university campus as a pre-commercial launch. And the plan is to take it to the Indian public operator as a large proof of concept, maybe at a city level deployment before we go a larger scale. So we solved the problem of indigenous radio access network development. We solved at least a good parts of it that we're happy about. So we have a lot of work ahead, but it's going in the right direction. But at the same time, some of our companies, we made some new inventions in the area of Open RAN. What we figured out is that the so-called massive MIMO technology that is in use today in the existing networks, it's not Open RAN compliant. And the Open RAN standards by themselves, they didn't do the best possible job of coming up with the best possible Open RAN massive MIMO standards. So there was a lot of discussion last year in the Open RAN community, and something new called uplink performance improvement. Basically, it's some kind of a massive MIMO technology in the radios was introduced. It's kind of ironic that our company has actually developed this technology some 5 years ago. And we did indeed talk to some players and they didn't show much interest. We have a lot of patents in this space. Actually, I would say we are the inventors of this ULPI technology from our company. So now this is a hot topic. I think United States is giving out $420 million. I think maybe half of it is meant for this radio technology, including, I'm sure, massive MIMO systems. So we're working with some chipset companies in the United States, moving our technology into commercially realizable massive MIMO radio units, compliant to Open RAN standards. I guess we are a year away to roll this out. So pretty exciting time. We are really in the middle of this open programmable system at the cutting edge of it. So these are two prime activities that we do. Other than my, contribution stories, ITU and 6G, get things going. Yeah, so that's where things are. Yeah, interesting times for us.
Yeah, good. Well, Professor Cucci, thank you so much for joining us here at the Hudson Institute. We look forward to hearing about more about the progress of WiSig and your research efforts and the development of 6G over the next few years. We look forward to having you back at the Hudson Institute soon. Thank you so much.
Thank you very much. I look forward to seeing you in Washington, D.C. at the earliest next opportunity.